So everyone, welcome back to Made Easy Academia. So please don't forget to like our video, share so that other two can be able to benefit from this tutorial. So our main discussion for today will be based on wave motions, especially equation of a wave. How can we use equation of a wave to solve? Maybe it might be either wavelength or the frequency or the amplitude or whatsoever. So I will explain all the terms one after the other. And if you download our material, you can see all this explanation of wave, the types of wave, and all the terms related to that wave as well. So now, let's first talk about wave itself. What do you mean by wave? A wave is a disturbance which travel through a medium and transfer energy from one point to another without causing any permanent displacement itself. So here, we have, like, for example, if I drop a stone inside the water, let's say we have a water like this, and we drop a stone inside the water, there will be compressor like this. So, and there will be a pop sound. So, you understand? So, and this wave is divided into two parts. We have what we call mechanical wave. At the same time, we have electromagnetic wave. So, what do we mean by mechanical wave? Mechanical wave is a type of wave that require material medium for their own mode of propagation. So, why the other one is electromagnetic wave? Are those type of wave that doesn't require any material medium for their own propagation. So, we don't need to worry about that. We have materials that you can see all these definitions. We have another one, constructive wave, destructive wave as well. And we have many examples like sound wave, radio wave, all those ones, you see them there. So now, and we have some terms related to wave like wavelength. We have wavelength. So when they say wavelength, it has a symbol, we call it a lambda. So wavelength is the distance between two successive crests or trough that are in phase. When we have something like this, let's say we have wave traveling this way. So it's just the distance between two successive crests or trough that are in phase. So we can have, we can travel either the same directions or different directions. Let me firstly mention the terms that we need here. We're talking about general terms. General terms of wave. We're talking about the amplitude. We're talking about the amplitude. At the same time, the wavelength. Then we have period. We're talking about the frequency. Then we're talking about wave speed. Wave speed. So those are the terms that we're talking about one after the other. So what we mean by amplitude is the maximum displacement of the particles of a wave from its mean or equilibrium positions. Let's say, for example, if I have a diagram like this. So how the wave is traveling from its initial position, but don't worry, we explain all this on our materials, so you don't need to worry about that. So this amplitude, I did tell you that what matters most in physics is if you are solving a problem, is to recognize a unit. The unit is what we use to recognize a given quantity. So this amplitude, it's measured in meter. It's measured in meter. So that's the SI unit of amplitude. Then the other one we have is wavelength. So I've explained that one too as well. That is the distance between two successive crests or trough that are in phase, and that one too also measured in meters. So the other one we have is the period, which is the time taken by the particle of a wave to perform one complete oscillation. The other one is common, just like the time for a wave to travel from one point to another. So now that one, we know that time is measured in what? Yeah, time is measured in seconds. So the other one we have is the frequency, which is the number of cycle or oscillation which the wave completes in 1 second. So meaning this frequency is just like the inverse of time. So frequency is the inverse of time. So, and this frequency is measured in hertz. So please, we are going to include all the definition of all these terms together with the types of wave, the main explanation of wave as well. So we want to base only on calculation aspect so that to save our time. So then the wave speed, normally we know, in general, even if you miss our videos on the equation of motion, we talk about this. We know normally speed is a distance over time. So, but you know, from here we say that the wavelength is the distance or the displacement, the distance between two successive crests or trough that are in phase. You know, normally we know the one that we know is usually that we know that either speed or velocity. We know that that one is a distance over time. So this is the one we know before. So now we want to relate this one to wave now. So we can say wave speed. So instead of saying distance, we use displacement. So that is we use wavelength rather. So that's going to be wavelength over time. So that's the formula for the wave speed here. But you know, I told you the frequency is the inverse of time, or we can say time is the inverse of frequency. So anyone we use out of the two, either we use the first one or we use the second one, it's still the same. We can say frequency is equal to 1 over t, or we have t to be equal to 1 over f. So in physics, we don't use our wavelength, we do need the wavelength as lambda. So whenever you see this, we call it a lambda, which is for wavelength. So if I go back here, I can have wave speed. So instead of saying wavelength is lambda, as a lambda over t. So this lambda that we put here is for the wavelength, and the t we have here is our time. So now from here, we say that time is the same thing as 1 over f. So if I substitute the value of time here, the period here, I can have the wave speed to be equal to lambda over. So instead of saying t, I can have 1 over f. So now we know if you have three values here, we can apply the law of reciprocal. If I apply the law of reciprocal here, I can have wave speed is equal to lambda f, or we can have f lambda. So those are the two formulas to find the wave speed. Either you use wave speed is equal to lambda over t, or you use wave speed to be equal to f lambda. So depend on the problem we are solving or the data given. If you are given the wavelength and time, you can apply the first one. If you are given the frequency and the wavelength, you can just apply the second one as well. So now, even with this, we can have like two examples. Or let me just solve like two examples there, so that you see how to make use of that formula there before we go to equation of a wave, because that's our main target. You know, wave is, we have many things on that wave. We have reflection, refraction, polarization, diffraction as well. But our main target, since the physics 102, this is general physics based on only equation of a wave, that's why we are going to use our argument under equation of a wave. So let's look at this problem. Let's look at this. They said a radio station broadcast at a frequency of 400 kilohertz. If the speed of the wave is 3 times 10 to the power over 8 meters per second, calculate the wavelength, calculate the wavelength of the radio wave. So now this is a problem. So I think it's simple and straightforward as well. They said, now look at the formula that we have for the wave speed. So wave speed can be lambda over t or f lambda. It depends on the data you are given. So let's see a question. They say a radio station broadcasts at a frequency of 400 kilohertz, meaning the frequency we have is 400 kilohertz. Even firstly, the value of the frequency we have here is kilohertz, and you know kilohertz means what? Yeah, 1000. So I can just save this one instance 1000. So that means what I have here is our frequency is equal to 400,000. So because the value that we have for the frequency there is kilohertz. So if the speed of the wave is this, that is, we are given the wave speed to be 3 times 10 raised to the power of 8 meter per seconds, and we have to find the wavelength of the wave. Now look at the data we have. Which one can we apply between the two formulas? Can we apply the first one? No, because there's no time. Abi? Now, can we apply the second one? Yes, of course, because we have the frequency at the same time, we have to find the wavelength. So from the formula we have, we know that wave speed is equal to f lambda. So now, if I make my lambda at the subject, divide through by f, divide through by f. So if this cancels, that we have wavelength is equal to wave speed over the frequency. So now, from the data we are given that the wave speed is given as 3 times 10 raised to the power of 8, and then we are given the frequency to be 400,000. So if you define this, whatever you get, that's going to be your result. So let's see that. We have 3 times 10 raised to the power of 8 divided by 400,000. So if you do that, what we have for the wavelength here, we have it to be 750 meter, because I told you that wavelength will also measure the meter. So it depends on the one that you are given from the questions, if it's required for you to apply the first one or to apply the second one. So now, let's now go to the main target equation of a wave. So under this, we have thousands equation for wave. It has many derivations, but there is one that can be used to solve a lot of problems under that of equation of wave. So I will give you that one. If the question comes involving the equation, just apply it. So the formula is given as this. Y, we call it an equation of a progressive wave. Equation of progressive wave. So it's given as this. Y is equal to A sine bracket omega t minus kx. In some materials, we have many equations apart from this one. But this one, I think, is one of the most general ones to find. As far as what you're looking for, you can use this formula to find them. So please, there are many equations. You understand? There are many equations. You can see material that will be different from this one. But believe me, if you can be able to master this, once it's related to either to find the wavelength, or to find the period of the wave, or to find the amplitude or whatsoever, you can just apply this formula. So y is equal to A sine omega t minus kx. So here that we use here is amplitude. So the A that we put here is just amplitude. All those are constant. Then we also have angular speed there, which is omega. You know, from our motion, we know that omega is equal to 2 pi over t. You know why 2 pi is one oscillation complete by its object per time taken. That's omega is equal to 2 pi over time. So let's see, this is equation 1. And from what we mentioned earlier, we said period is the inverse of frequency. Now, if I substitute the value of t to this equation 1, we can have omega equal to 2 pi over. So instead of saying t now, we are going to use 1 over f. Now, I can apply the law of reciprocal here now. So meaning we can have omega is equal to 2 pi f. So let's say this one is our equation 2. So now, the first one, it depends. If you have to find the period, and you have been given the value of your omega from the equations, you can just apply equation 1. Or if you have to find the value of the frequency, if the omega has been given, we can apply the second equation. Now, we also have our k front is 2 pi over lambda. You know, recall that the wavelength is the distance between two successive crests or trough that are in phase. So now we can call this equation 3. This value or this formula can be applied if you have to find the wavelength, and from the equation the value of k has been given. Because this equation you'll be comparing with the general one you are given. Either any problem you are given, just master the equation and you compare the two. So now, and the one we have here, we say that the wave speed can either be lambda over t, or we can have it as f lambda. We derive this together. So those are the equations that we need under equation of a progressive wave. So the first one we said omega is equal to 2 pi over t, one oscillation per time taking. Then we said omega 2 can be 2 pi f, or we can use from here that we know that period is equal to 1 over f, which is frequency, or frequency also equal to 1 over time. So, and from k, which is wavefront, we have k is equal to 2 pi over lambda. That is, if we are solving a problem, if the value of k is known, then we can be able to find the value of our wavelength. Then from the two formula we have here, we said wave speed can either be lambda over t or f lambda. So those are the formula that you need under the equation of a wave. So let's see some examples and see how we are going to apply them. So this is what we have for the general equation of the wave. We said, let me write it here, y is equal to, it's very important, a sine omega t minus kx. And we derive all those formulas. We said omega is equal to 2 pi over t, and we have omega 2 to be 2 pi f. We derive another one. We said just know this one too, either 1 over f or f is equal to 1 over t. And we have another one, we said k is equal to 2 pi over lambda. And we say v is equal to f lambda, or v can be equal to lambda over t. So these are the ones that we derive. So let's see how we are going to apply this formula. Let's see question 1. We say given that the equation of the wave is y is equal to 10 sine open bracket 50t minus 100x. So determine the value of figure 1 amplitude, figure 2. Let's see figure 2. We have to determine wavelength. Figure 3. Let's say frequency. Figure 4 period. Figure 5 the wave speed. So taking pi, maybe we are given pi here to be 3.14. You know, pi can be 22/7, 3.142. It depends on the one you are given from the problem. So here we are asked to take the pi to be 3.14, right? Yeah, fine. So now this is what we have from the problem. They said y is equal to 10 sine open bracket 50t minus 100x. So the first thing for you to do, you compare it with the general equation that we have. You know, this is the general equation that we have. Would you call that? Yeah, fine. So just compare the two together. What do we have there? We have y is equal to a sine open bracket omega t minus kx. That's the first step. Are you following now? The first step to be considered, you will take the equation given to you and compare it with the general equation. So now, by comparison, we can see y for y. Can we see that? Y for y. Then a for, yeah, good. A for 10. At the same time, sine for sine. That is omega for 50. Then at the same time, what's going to be the value of k here? Yeah, good. So the value of k is going to be 1. You just see, you can see, we just have to compare it to the one given from the problem. So our a is equal to 10, our omega is equal to 50. At the same time, our k that we have here is equal to 100. So the first question is said, you should determine the amplitude. That's the first question. You should determine amplitude. You know, look at the equation. We say that a here in the equation, a means the amplitude. So that means from here, we have our amplitude to be 10. And don't forget, we said amplitude is measured in meter. You can see how we determine the amplitude. Just so simple. By comparison, we have the amplitude to be what? The amplitude to be 10. So the second question, they say we should find the wavelength. So look at the equation. Which one can we use to find the wavelength here? Can we apply this one or this one? Yeah, the answer is no, because we don't even have the frequency, talk less of having the wave speed. So which one can we apply? We can only apply this one because the value of k has been known. So now we can have k equal to 2 pi over lambda, right? Good. So if you make your k lambda the subject, if I cross multiply, and we have lambda k is equal to 2 pi. So since I'm looking for lambda, divide 2 by k. Divide 2 by k. So if this cancels this, we have lambda to be equal to 2 pi all over k. So now we can have lambda to be, so from the equation we have, this is 2 multiplied by, and we have to take our pi to be 3.14. So it depends, in some situation we have to take your pi to be either 3.142 or 22/7. So you just check, and if the value of pi does not sit there, you can use any of the three. You are going to get the same result. So from here we have 2 multiplied by our pi that we have is 3.14 divided by, now from equations you can see what's our k here. Yeah, good. Our k is 100, so I have this one to be 100. So here we have lambda to be 2 multiplied by this, and we have 6.28 divided by 100. So 6.28 divided by 100, here we are going to have 0.0628 meter. Get that? So fine. So let's check the next question. They said to find the frequency. So can we apply this equation? No, because the value of the wave speed is not known. Which one can we apply? Check. Which one can we apply? Can we apply this second equation? Yeah, good, because the value of our omega has been known. So now let's find it here. The third one, we have to determine the frequency. So from that equation I have, we know that omega is equal to 2 f. So now I want to make my f at the subject. So if I divide both by 2 pi, divide both by 2 pi. So if this cancel this, I will have frequency to be omega over 2 pi. So from the data we are given that omega is equal to 50. So we have 50 divided by 2 multiplied by, so our pi that we have is at 3.14. So here we can have the frequency to be, so we are with that. So here we can have the frequency to be 50 divided by 2 multiplied by 3.14, we are going to have 6.28. So now if you divide the value, 50 divided by 6.28, of course we are going to have 7.96. So here we have the frequency to be 7.96 hertz. So which means our frequency that we have here is 7.96. So now the next step, so let's see the next question. We have to find the period. You know, if I want to find the period, I can apply equation 1, which says that omega is equal to 2 pi over t, but you don't need to waste your time. If you ask, note one thing here, under this equation of the wave, if you ask to find either period or frequency, if one of them is known, either you have been given the period and you have to find the frequency, or you are given the frequency and you have to find the period, you can just apply this short formula, which is t is equal to 1 over f, or f is equal to 1 over t. So from this solution, we know our frequency to be 7.96. So we don't need to waste our time using this one. But if you apply that one, you are going to get the same result. But since you don't need to waste your time, you can just apply the short one by saying time is equal to, which is period is equal to 1 over frequency. So let's put it here. So that's the fourth one. I think this is the fourth one. Go. 1, 2, 3, 4. So I'm looking for time. So we know time, this period, is equal to 1 over f. So what I got for f now, I got 7.96. So I'll just say 1 divided by 7.96. 1 divided by 7.96. So what we have there, we have it to be 0.126. We have 0.126 seconds by approximation. So our time, our period is equal to 0.126 seconds. So the last question is able to find the wave speed. You know, we have two formulas for wave speed. We have wave speed to be either f lambda or lambda over 2, lambda over t. So now here you can pick any one of your choice, since all the values has been gotten. So we got the value. We have only got the value of frequency, the wavelength, the period as well. Anyone you use out of the two, you are going to arrive at the same result. So now if I pick equation 4. In equation 4 we have v is equal to, wave speed is equal to f lambda. So now my frequency, I got the frequency we have here is at 7.96 multiplied by our lambda that we have here, which is wavelength. Our wavelength we got here is 0.0628. So now you just multiply the two together. Whatever you have, that's going to be your result. So in some situation, in that equation of a progressive wave, it might contain a pi. So note one thing, if you are solving a problem and it contains a pi, it means we are solving the problem in terms of pi. That is, the pi will cancel, we later cancel each other. Let's see one question from there. Okay, let me just, okay, don't worry. Let me just clean it. All right, another problem. So let's say we have y is equal to 100 sine 10 pi t minus 40 pi x. They said determine, so they said find, maybe the same questions, amplitude, wavelength, period, and let's say wave speed. So now, so if you look at the equation, you can see in that equation we have a pi there. So mostly, if you are solving a problem under the equation of a wave, if you see a pi there, it means that that means something is you have to solve a problem in terms of pi. So we have y is equal to 100 sine open bracket 10 pi t minus 40 pi x. So by comparing to that equations, we have y is equal to a sine open bracket omega t minus kx. So now by comparison, that is y for y, can we see that? Then a for 100. So here I can even have to find the amplitude, that is a meter. Already we have got that. So now if I compare this, our omega here is going to be 100 pi. Then our k here too is going to be 40 pi. So now the first question they said, the second question they said we should find the wavelength. You know, from the equation itself, we have gotten the value of our amplitude. So now they said we should find the value of the wavelength. Recall, you say if the value of k is known, then we can find the value of our wavelength from that. So we know that k is equal to 2 pi over lambda. So if I make my wavelength at the subject, that means I can have my lambda here to be 2 pi over k. So now we can have this one to be 2 pi divided by, so our k that we have is 40 pi. We have 40 pi. You can see pi cancel pi. So that means I can have the wavelength to be, so 2 divided by 40. So 2 here, 1, 3 in 40, we are going to have 1 over 20. And you can even convert this one to standard, to decimal numbers. 1 divided by 20, if you do that, we are going to have 0.05. 0.05 meters. So I will leave the other one as exercises. You can find your period, right? Or I should finish it. Okay, so let's finish it together. We can find our period. We know t. We know that omega is equal to 2 pi over t. So the same method, if I make my period at the subject, we are going to have period to be 2 pi over omega. So now we are going to have 2 pi over, so the omega that we have here from the equation, we have to be 100 pi. So we have 100 pi. So now you can see pi can cancel pi. So here we have t is equal to 2 divided by 100, that's 1 over 50. So if you want to convert to decimal number, then you can have this one to be 0.02 seconds. So assuming you have to find the frequency here, you can just also make use of frequency equal to 1 over f. So 1 over t rather, then you can just make some simple substitution. So now we have to find the wave speed as well. So we'll leave that one. So wave speed is lambda over t. So here we have gotten lambda to be this. At the same time we have our period. Just make a simple substitution. So that's what we have for equation of a progressive wave. So in case if you need another materials concerning other part of wave, we still have sound wave, reflection, law of reflection, refraction, polarization. So you can kindly contact us. So please don't forget to like our videos, share, and subscribe so others too can be able to benefit from this tutorial. So thanks for watching.